We continue on going back to some vocab, and we're going to look at an inscribed angle. An inscribed angle is an angle inside a circle that goes all the way to the outside edge of the circle. So this angle right here would be an inscribed angle. One interesting property of inscribed angles is that the measure of that angle is half of the arc length. So for example, if this arc here measured 94 degrees, then this angle, this inscribed angle, would be half of that, so that would be 47 degrees. So you just take whatever the arc is, cut it in half, or you take whatever the inscribed angle is and double it. The way I remember this rule is I think of a full circle with a line on the outside. Because if you have a line, an angle that's a straight angle here, you have 180 degrees. And if you have a full circle all the way around the circle, you have 360 degrees around the arc. So a straight line on the outside, 180, is equal to a 360 degree path around the entire circle. So it's twice as much. So that's kind of how I remember. You can also tell that the arc here covers more ground around the circle than the angle because it's all the way to the edge. So a few ways to remember that one. Let's go to our example. We need to find x, y, and z. So let's zoom into our picture. First thing we have here is 100 degrees, and I'm going to look at x first. We have a 100-degree arc along the outside of the circle. If we take that and divide it by 2, then we can get our smaller angle inside, 50 degrees. If you find that you forget when you're halving and when you're doubling, you can think about this as trying to be 200 degrees and look at it and say that is definitely not a 200-degree angle. 50, however, makes a lot more sense based on the picture. So a little common sense check can help sometimes. If we jump over to z, we're looking at this arc, and as of right now we have no idea what that arc is. So we're going to skip that one for the moment. Let's go over here to y, and y is the arc. So it is not the inscribed angle. Y is the arc. And the arc is always twice as big as the inscribed angle, so that 34 is going to double to 68 degrees for an arc. Now with this last one, we can go back to it. We have everything else filled in. If we take our path around the circle, we add up what we've got. We've got 62 plus 100 plus 68 plus 76. I believe that's 76 there. So we add that all up and we get 138, 238, 298, 306. So we have 306 used up. That leaves us with only 54 degrees left over, making z only half of that number, which would be a 27-degree inscribed angle. So you can always check your work then by going back and adding up all the angles around the outside of the circle to make sure it equals 360. The inscribed angles, if you add those together, there's not necessarily going to be a pattern there because there's no starting point for those. So don't expect these to add up to anything special. In the next example, we need to find x. And here we have 254 degrees along this large arc here, leaving us with this arc being 360 minus that. So we have 106 degrees to get up to 360. Add those two together, we do get 360. The thing that we're trying to figure out is this x, this angle down here. And that angle goes up here and then back down here. So that is the angle that we're trying to find the measure of. Like above, even though the picture looks a little different, same basic idea. We take our 106, divide it by 2, and we get 53 degrees for x. So x is 53 degrees. We go down to example 4. We need to find the arc of DW. DW is a minor arc, shorter arc, so it's going to be this side here. Our inscribed angle is 52, So we double that, 2 times 52, and that's 104. So we have 104 degrees. Example 5, we're finding x. We have the arc. We're going inside the circle, so we do not double, because that would make this 150 something degrees. We don't want that. We want to cut that in half. So 76 divided by 2, 35 plus 3 is 38 degrees. This is going to be our x. 76 divided by 2. And then finally, one more example here. We're told if EDG is 85 degrees, this angle here is 85, find GDE. GDE. We go through D. We need to find that arc. Here's the issue, is that this 85 degrees here is going to tell us this side right here, because we're going to take that 85, double it, and get 170 over here. However, the benefit of that is, since we know the whole thing is 360 and it's either the red or the brown, we can take 360 minus the 170, and that's going to leave us with 190 degrees over here. And that's all for our examples.